Hello Paul, hello and community of developers interested in Arduino with Python. So this is my proposal for exercise number 4 about the goal was to create an analog display for the Arduino voltage input via serial interface with the potentiometer. So this is my proposal. Here those are the variables that can set up main sizes for the dial radius, thickness, inner radius, range, which is 5 volts here. The arc will be flat, like 180 degrees. The scale is computed by the arc divided by the range, which in this case will give 36. The precision, how many ticks we want for this range. Precision will be half volt for the dial, and the dial step will be computed dividing the scale by the precision. So it will be 18, 36 by 2 here. Needle angle will set the angle of the needle, analog needle here. It's initialized at 0. We start by drawing here the shapes of the two arcs that will represent the dial itself. Nothing special. Then the needle here, and we create a variable here to get a reference to the extrusion object, which will allow us to make it rotate further. Then we draw all the ticks here for the and for each value, for each integer value, for each volt, we draw a label here at the right position. I could have used the red angle earlier. Oh, it's okay, just an optimization for later. The radius angle is the angle converted in radians here with radians, which allows us to compute the position of the start position of the tick and end position of the tick here. There's just trigonometry, of course. And then we draw the line from start to end. Okay. For some reason, I had problems with the last tick. If I draw the last tick, even with one more step here, it stucks the whole loop, and I cannot exit the loop. So my solution here was to explicitly draw the last tick here, which is at the radius of the flat angle, of course. Then the digital display, we added a digital display in the center of the dial here, which will help us debug and have more precise values when we want to. We have a signal to unit ratio, so 1033 is the maximum signal we get from the Arduino, divided by the dial range will give us a factor, will allow us to make the conversion. This is the algorithm to get the data here. There's nothing new, it's from your code. I took it back. Then we compute the volt. The volt is the data divided by factor with 4 decimals here, and we can set the text of the label, the digital display, at the volt with 1 decimal only, and I give also the signal just to check it's consistent with the signal. This is for debug purpose. The problem here is that we can rotate the needle, but it's a relative rotation, so we rotate by an amount of degrees, by a certain angle. It's not absolute from 0, so we need here to keep the previous angle, see what the new angle is and compute the difference between two. That gives us the needed rotation, which is the evolution. I call it the evolution. Okay, so we rotate by an angle of the needle rotation. It's counterclockwise, so I just inverted it as a minus sign here. So let's see. We run this. Oh, this is, I'll show you maybe first. I don't have the same gear as you for the camera, so I'll just show you my blinking Arduino here with the potentiometer. And I will launch now the code. It should work. Yep, this is it. Okay, I'll do it again so we can see maybe the drawing of all the ticks. Just do it again here. Yep. Okay, so you see all the ticks drawing by the precision. So we have a scale of 5 on 180 degrees. So it makes with a precision of 0.5, makes an intermediate tick between each value here. And then the needle, we have now 1/10 of a volt with a signal which is 30, so it's somewhat consistent. I see if I go further. .2 volt, yes, the position of the needle is consistent. We go to the maximum maybe. And you see now it's 5 volts, signal is 1021, so oscillating 21, 23 is not very stable. And that's it. Thank you for watching.